Today, I will be talking about chain rule. I received a question about my last video, a challenging question. In that video, there is one step which requires chain rule. And the question I received is that requesting a slight detailed explanation of the chain rule. Now I'm doing that. The step in my last video is a relation of this equation. The next step is to find the derivative of the left-hand side and also the right-hand side. To find the derivative of the left-hand side, I need the derivative of the first term and the second term. The second term is x squared. The derivative is very simple. But the first term is f of x squared. So how do you find the derivative of this thing? You need chain rule. So let's start. Let us represent f of x by the letter u. Therefore, the derivative of f of x squared is the derivative of u squared. When you do the derivative, you have to say the derivative is with respect to what variable. In this question, the variable is x, so the derivative is with respect to x. So what is the derivative of this? Let me rewrite u as f of x squared. And let's see now. Okay. Let us multiply this part by a factor 1. But I'm not going to write 1. I'm going to write du by du. Because du by du is just 1. So I multiply this part is just 1. I multiply by 1, I do not change anything. But now I do a trick. Let me give you a very simple example before I do the trick here. Suppose I have two fractions multiplied together. A over b multiply c over d. You know, you multiply the numerator with the numerator. You multiply the denominator with the denominator. But multiplication, you can switch. A times b is the same as b times a. So I just rewrite b and d. I switch the order of b and d. The top is a multiplied c. The bottom is b multiplied d. And I can rewrite as d times b. Just switch. Okay, this simple illustration will be applied to here. So the top, I keep it, but the bottom, I switch dx and du. Therefore, switch the denominator. There is no problem because we understand that. Now, I replace f of x by u squared. Okay. This step has no problem, right? Because f of x, I use the letter u to represent it. But then du squared by du is not difficult. What is the derivative of u squared? It's 2u. What is the derivative of du by dx? U is f of x. The derivative u with respect to x is the derivative of f of x with respect to x. Okay. Let me use this corner to write this, to continue this part. U is f of x. Therefore, it's 2 times f of x times the derivative of f of x. So I can write this u is f of x. Derivative of f of x, you can use prime notation, f of x prime. And that is the step in my last video, a challenging question. So what is chain rule? Chain rule, let me write down the general rule of chain rule. I need to erase something. Okay. This is chain rule. You have a function y. You want to find the derivative of y with respect to x. The chain rule says that you do the derivative of y with respect to another variable u, and multiply the derivative of u with respect to x. This formula is called a chain rule. As I said at the beginning, I'm going to show you how to use the chain rule, but I'm not going to prove the chain rule. To prove the chain rule is beyond the level of high school calculus. There is one textbook which says to prove the chain rule, you need university level, not only that, advanced university level. So here I'm just going to use how to use the chain rule. Now, there is a simple way to remember the chain rule. Look here. Suppose you consider these are fractions. Then it's obvious that du and du can be cancelled. After you cancel du, you get dy by dx. That's how you remember the chain rule. But one thing you need to know that in calculus, du by d something, dy by dx is just a symbol. It's called the Leibniz symbol. It is not actually a fraction. Yeah. Remember that. It's not a fraction, but you can consider that as a fraction. That will help you to remember the formula. Okay, let's have some examples. I have a function. Y is equal to square root of ax. What is the derivative of y with respect to x? So I let u represent ax. And I need to explain what u is. U equals ax. Now, the derivative of y with respect to x, you use chain rule. Here, once I represent ax by u, I don't need to look at this. So y is this. Y is a function of u. Let's do the derivative with respect to u. This is just rewrite u to the exponent 1/2. So this is the derivative of y with respect to u. It is a simple power rule. No trouble. What is the derivative of u with respect to x? It's just a, right? This is simple. Okay. Now you multiply. You multiply this by this. As I said a few minutes earlier, this multiply that. You cancel the u. The result is dy by dx. So this is the result. And this is the result of applying the chain rule. And all you need to do is to replace the u by the original okay, so this is irrelevant. This is my example. So this is u is square root ax, and you have no. U is ax. And then times a. So this is finally dy by dx. So this is the final result. Of course, you can simplify the root a, and this a you can simplify a little bit. But this is how you get the final result. Let me give you one more example, and that is our chain rule application. One more example. So it looks very complicated. But if we use chain rule, we can write this way. Okay. You call this whole thing U. And you call this whole thing V. So I have these three relations now. Y is long U. U is cotangent V. V is this. Do derivative. The derivative of natural logarithm is just 1 over the variable. The derivative of cotangent is negative cosecant squared. The derivative of this polynomial is just using the power rule, 8x. Multiply this and this and this. That's the derivative of dy by dx. Look, du here cancel. dv here cancel. What is left is dy by dx. That's exactly chain rule. So that's the result. That's the derivative. All you need to do is substitution back. U is cotangent V. Put cotangent V here. But V is this. So it's cotangent that. Put it here. And this V you need to replace by that. That's all. After you do that, you simplify it. And that is your final answer. Why this is called a chain rule? It's this times that. It is like a chain. You have a steel ring, and steel ring is linked to another steel ring. And this is linked to another thing like that. And you can keep on going. That's a chain. Exactly here. This is linked to this. This is linked to this. You multiply everything, you get final result. And that is the chain rule. So, okay, that is what I want to talk today. See you next time. Goodbye.